Perchloric. All right.
63.
I gotta start saying the number, then the question.
All right, let's ask ourselves, where do we get that ic ending from? Huh? We said it a minute ago. We get the ic ending from what? It is a polyatomic ion. What kind of polyatomic ions have would become ics if we name them like an acid? What is the polyatomic ion? Eights. Eights become ics, but ides also become ics. Okay? But any ide ending is going to also have hydro in front. There's no hydro out here, so this must have an 8 ending. Okay? So if you remember when we're naming acids, binary acids, we name it like an ionic compound, they have an IDE ending. Like hydrogen sulfide or hydrogen chloride. That's a binary acid. That became hydrosulfuric or hydrochloric. Binary acids have hydro on the front. Since this doesn't have hydro on the front, this ic must mean we have an 8 ending on the polyatomic ion. So we're going to look for a perchlorate ion on the common ions list. Perchlorate. Okay? You go to the common ions list and there is perchlorate. Right there. It's ClO4 with a 1 negative charge. Okay? What do we always have in an acid formula? H is going in the front. What charge do the acids what charge does the hydrogen in an acid have? Always 1 positive. That's just something you got to know. Okay? If you look on the periodic table with oxidation numbers, you'll see hydrogen actually has 2 different oxidation numbers listed up there. You have to know, in an acid, the hydrogen always has a 1 plus charge. Okay? I don't make you memorize a lot, but that's one thing you just got to know. All right? So now how do we put those together? Let's see. 1 plus, 1 negative. The whole thing equals 0. Coefficients of 1 and 1. So I don't need to put any coefficients in the formulas. And I can put them together as HClO4. Okay? You're very welcome. 62. What now? HClO4. Perchloric has 4 oxygens. 65. When magnesium and chlorine... 62, I'm sorry. 62. Write the formula for dichlorine pentoxide. Dichlorine... I put pentaoxide in the formula, but really pentoxide is even better. Oh, okay, sure. Move it down so you can see it. There we go. All right. If I have prefixes like those, what does that tell you? What kind of compounds it tell you it is? It is a covalent compound. Okay. All right. So dichlorine. That means I have how many chlorines? 2. And how many oxygens?
5.
There you go. Good for you. Good for you. Yes, Darrell?
I got 2 single bonds are formed by covalent bonds.
Single bonds are formed by the sharing of electrons in a covalent bond, yes. Single bonds are formed by the sharing of 2 electrons in a covalent bond. Okay? Most of the time, each atom brings 1 electron to that bond. But on some occasions, like when we put a hydrogen ion onto ammonia, both electrons come from one thing. Yep.
And my other one was, what kind of bonds do they embed in a triple bond?
What kind of bonds do you have in a triple bond?
Double and triple.
Okay, in a double bond, double bonds you've got a single bond, a sigma bond and a double bond. Pi bond. Okay? And in a triple bond, you have one sigma bond and you have two pi bonds. Wait a minute, I think Cheryl Hannah was up first here, and then we'll get that, okay? What's your question?
For 100, what is a good model?
A model. Okay. So models in chemistry, models in science.
Wait, can you see that down just a bit?
Models in science are not usually physical models, and we do it sometimes. And we did physical models of orbitals, and we used balloons to show that, right? And we did physical models of the shape of bonds in molecules by using those long balloons. But even that is describing behavior. So models in science are describing the cause of some behavior. Okay? So a good model has to describe the cause of some behavior. But it has to be more than just that. Okay? If you've got a friend that, for no apparent reason, chews you out one day, you probably could come up with a reason in your head for a cause for that behavior, couldn't you? But in science, we want to do more than just come up with an opinion. Okay? In science, a model has to be based on previously existing science. Solid, previously existing science. It has to be based on physical explanations. And like everything in science, it must be testable. Everything in science has to be testable. And by testable, we mean that you have to make the claim in a way that experimentation could show that it's wrong if that information can be found. Yes. Yes. You have to have a reasonable expectation that it's possible to find contrary evidence that would disprove the model. That makes sense? So you can't write the model in a way where you cannot disprove it. All right. So those are the four critical things really. Cause of behavior based on science, physical explanation, and then that it's testable.
And scientific principles, didn't you say that yesterday?
What's that?
And it's also built on scientific principles.
Yeah, well, previously existing good science, yes. Scientific principle, that's true. Okay? All right. Now, are you, what, Brandon? 69 and 70. The sum of oxidation numbers in a neutral compound, 0. All the balancing of those ionic compounds we've been doing so far, coming up with a 0 charge, right? Okay. 70. Sum of oxidation numbers in a polyatomic ion. So in all these polyatomic ions, the sum of oxidation numbers is the charge on the ion. So if there's no charge, then you've got a 0 overall charge, and so the sum of oxidation numbers is 0. If there's a charge on the particle, then you've got to have a sum of oxidation numbers that adds up to that charge on the particle.